Hello guys. Sorry about that. I started without clicking the stream button, so I was on my own for a bit there. Yeah, comment your names and let's do this register. So we've got Sam, we've got Hannah, we've got Sam, we've got Dan, we've got Casper, Samuel, Kezia, Regan, Joseph, Zach. Cool. Anyone heard from Will, Sam, Lottie, Carrie, Frank, or Isaac? No. All right. So, yeah, finished that paper last lecture. Today we're going to start the next paper, which I reckon we can get through today and tomorrow. So this is the 2018 paper, I think A2 paper 1, I think. Anyway, so we're going to work our way through this like we did yesterday. Next week we're going to do stuff a bit more interesting. We're going to, oops, I just turned off the iPad. Next week we're going to look at something other than past papers, because I know past papers can be a bit dull. Just wondering why that hasn't loaded back up yet. Don't say the iPad's down. That's really weird. Let's try that again. That's better. Cool. Yeah, so Kara's here, she can't type. Cool. Did we not? I thought we finished the mechanics paper off. Do we not? Are we behind where I thought we were? Let's check. Sam, where did you think we were? Because I thought we'd finished that and we were on to this one now, but maybe there was a couple, had the last stats questions to finish. Okay, let's have a look. But that's the plan, is that we're going to go past papers this week, and next week we're going to look at individual topics to revise. Oh, I just wait for this to load. If it will ever load. Okay, was it this one? Depth question 5, but not beyond that. Oh. Okay, yeah, this all rings a bell. Cool. Sorry, I was jumping ahead a bit there. So we did question 5. Oh yeah, 5 minutes Thursday starter today. Cool. So we haven't done this one. Ah, cool. All right, we're a lecture behind where I thought. No problem. All right, so today we'll be finishing this one. Did I give you any time to start this question last lecture? Do so. Let's just do it today. I think I gave you the hint. I don't remember if we actually did it or not. Have you guys attempted this in your own time yet? Yes, need 5 minutes to finish it. Okay, cool. I'll give you 10 minutes because it's a hard question and you might need that time anyway, and some of you might have forgotten what you were doing. So I'll give you 10 minutes to get stuck into this one again. and then we'll go through it. So 10 minutes starting from now. Sam, you don't really get it. Okay. Part A is a binomial. No, it's not. Part A is a normal, so we're looking for the probability x is greater than 16. We then want the calculator to stop working. Well, we've already worked out the probability it's going to last. A battery will last more than 16, but she has 4 batteries, and they all need to be working, so that's a hint for that one. Part C, she only has 2 batteries, so she's got 2 batteries with that probability, and she's got 2 new batteries, so we need to work out a new probability for those. And then part D is a sample mean test, so it's all to do with the probability you work out in part A, and then kind of like you got 2 batteries of that, so that times that. That's the hint. So in 10 minutes we'll go through it, but if you are stuck, just try moving on to part D and see if you can do that bit. Cool. All right, guys. Yeah, tricky question. Tricky question indeed. So first bit, find the probability a random battery will last for longer than 16 hours. So if I write down the distribution, L is a normal with a mean of 18 and a spread of 4. So we get that. And we're looking for the probability that X is greater than 16. So if I bring up the calculator, we are looking then, statistics, distribution, normal distribution, NCD. Our lower is going to be 16. Upper big number, sigma is going to be 4, and mu is going to be 18. So type all that in. We get our probability is 0.691. So that's the answer. 1 mark. So yeah, pretty fair for that one. Next one. Okay, so at the start of her exam, she puts 4 new batteries in the calculator. She used it for 14 hours. She has another 4 exams to sit. Find the probability it will not stop working for the remaining exams. So basically, we've got a conditional probability question. We want to find the probability L. I should have used L earlier, but I didn't. L will last for 20 hours, given it has already lasted for 16 hours. Okay. Right. Now the probability that the calculator is going to last for 16, we need to times that by each battery is the only issue here. So we're going to need to work this out, and then we're going to need to times it, do it to the power 4 because there's 4 batteries in her calculator. So if we use the equation A given B equals A NB over B, our conditional here is going to be the probability that L is greater than 20 and greater than 16 divided by the probability that L is greater than 16. So greater than 20 and greater than 16, we can kind of condense that and say, well, if it's greater than 16, it must be greater than 20. So L is greater than 20 divided by L is greater than 16. So greater than 20 kind of incorporates both of those conditions on the top there. So our denominator is going to be 0.691. The numerator, we can do the same thing on the calculator, but using 20 as our lower value, which gives us 0.30309. So I'm going to write that in 309. And this will be the probability that one battery lasts for 20 hours, given that it's lasted for 16 hours. So if I divide those, 0.309 divided by 0.691, we get 0.447. Okay, so that's the probability one battery will last for 20 hours, given it's lasted for 16 hours. But we're asked for the probability the calculator will not stop working. So the probability the calculator will not stop working is going to be that 0.447 to the power 4, because there are 4 batteries in the calculator. So do that to the power 4. Probability it won't stop working is 0.03, 0.04 when we round up, 0.04. So 4%. So it's quite unlikely that her calculator will last. So she's only got 2 new batteries, so after the first 16 hours, although it's still working, she selects 2 of the batteries and replaces these with 2 new batteries. Alright, so we've already worked out the probability of those batteries lasting is 0.447. So we still got two of those batteries. She's only replaced two of them. So we're going to have 0.447 to the power 2 times by, we need to work out the probability that the battery lasts for 4 hours, because we've got two there that have lasted 16. We want them to last another 4. And she's put two new ones in. So we want to find out the probability that the two new batteries will last more than 4 hours. So bring back the calculator again. This time our lower is going to be 4. So you get a much bigger probability, 0.9997, or 9998 we should say. And we're going to square that and then times all these bits together. And we get 0.1997. Mine's actually slightly more than what they've said. Maybe we've rounded up slightly. Yeah, I did round up there. I still get the same thing. I'll check that in a minute, but I think we must have rounded somewhere. So I get, yeah, 0.991997. So interesting, but yeah, fine. Okay, any questions so far? Because those are the kind of the hard bits. The next bit's relatively easy. Anyone got any questions about these? No? Cool. All right. So last bit is the hypothesis test. So she believes the lifetime of the batteries was more than 18 hours. She took a random sample of 20 and found the mean was 90.2. State your hypothesis clearly, test her belief. So we've got the mean lifetime distribution. We're trying to test whether the mean is 18. And standard deviation is going to be 4, or the variance will be 4 squared divided by 20, which is our sample size. Our null hypothesis is that L equals, or mu equals, I should say, mu equals 18. And the alternate hypothesis is that mu is greater than 18. So we're going to do find our critical regions, testing at the 5% level. So if we look on our calculator, we need to go to inverse normal, tail to the right, 0.05, so 5%. Standard deviation is going to be 4 divided by root 20. Mean is still 18. Hit equals, and we get 19.47. So our critical region is greater than 19.47. She got 19.2. That's less than 19.47. So 19.2 not critical. So we are going to accept H0. There is not evidence to suggest the mean is higher than 18. Cool. Everyone all right? Anyone got any questions? I'll wait a minute to see if anyone does have any. Right, next one. So starting mechanics. It'd be nice to get through this today. I'm not too worried if we don't though. So start off with we've got looks like a calculus-y kind of question there. So if you guys could try this, how much was it worth? Was it 4 marks? Yeah. Oh, 6 marks. Okay. 6 minutes then, starting from now. Comment if you need any help or if you get stuck. down to 2 root 226. Might be right, that rings a bell actually. Okay, so we got velocity, we want to find a distance, so we're going to integrate to find our displacement equation. There's a few ways you can think about it. So S equals integral of t to the minus t. So we're going to get t to the half minus 2t squared j. Now there's two ways to do this. You can either use a plus c. Yeah, I think it's just plus c. There we go. Cool, so we're going to put in, do we know anything actually? No, let's not use plus c. We don't need it. Okay, normally you'd have plus c. Sorry guys. So yeah, we're going to integrate it. Normally you'd put plus c, and then we try and find plus c so we could find out the initial position of the particle. But we don't actually care about where it starts. All we care about is it's going from A to B. A to B. So all we care about is that part of the journey. We don't care about where it came from at the origin over there. So we don't actually need to find plus c. We're just going to go straight in, find A, find B, find the distance between them. Because we're concerned with the distance between two particles, we don't actually care where they are. So they could be anywhere on the axis. Their distance will still be the same. We don't need to find their true positions in order to find the distance between them. So I'm going to sub 1 in to find the A, let's call it SA, is at 2 minus 2i minus 2j. So 2 minus 2. Same thing for B. For B, we're going to put 4 in, so we're going to get 2 times root 4, which is 2 times 2 is 4. And for the J component, we get 2 squared, so that's 16, so that's minus 32. So that's where they are relative to each other. Again, I say it's not relative to any origin. So to find the distance between them, I'm going to subtract them and square them. It doesn't really matter what way around I do this, because again, we're trying to find the distance. So we'll do 2 take 4 minus 2 minus 32. 2 take 4 is minus 2. 2 minus 32 is the same as 2 minus 2 plus 32, which is going to be 30. So our distance is going to be 2 squared plus 30 squared square rooted, which is going to be root 904, which, as Dan said, is 2 root 226. My mic is real quiet. It's probably because it was on my head. I'm hoping that was from before. Do you have to give as a third, or is 2 minus 30 okay? No, because it wants a distance. That's the displacement, Sam. So you lose the last mark. You need to give it as a distance. A distance is not a vector. Cool. Good questions there, guys. On to the next one then. Okay. Interesting one here. Hopefully you guys can see that just about. Let me know if you can't see that, but so that's going to be 8 marks to do this one. So 8 marks, 8 minutes. I'll start the clock now. Let me know if you need any help. Regan, that is correct. Well done. Cool. All right. Yeah, some good answers. Regan, Kezia, Dan, all looking correct there. Okay, so we want to find the acceleration of the crate. You just got to be careful you don't miss out forces. So let's label a force diagram. So we've got tension there, obviously. We've got reaction force up from the ground. We've got the mass of the crate, 20g. And we've got friction opposing the motion. And we're moving that way. Cool. All right. So we need to resolve up first. So resolving up. So we're going to get R minus 20g. And the first trick is to not miss tension. So tension is acting this way, which is actually pulling it slightly up. You can see that arrow is kind of pointing a bit up. So we can resolve this tension upwards to find how much of this tension is pulling this object upwards and relieving the friction. So R minus 20g plus 10 sine alpha, no space, equals 0. Okay, so we can say R equals 20g minus t, and then sine alpha, well, tan alpha is 3 over 4. Draw a little triangle. Alpha, 3, 4, 5. sine alpha is going to be 3/5. So we get 3/5 of t there. Oh, and t's 40. Cool. So we can actually work out what r is. So 3/5 of 40. So, oh, cool. All right, if we work that out then, 3/5 of 40 is 24. So we've got 20 times 9.8. Take 24, gives me a reaction force of 172 newtons. Okay, now we're going to resolve horizontally. So we've got T cos alpha minus the friction equals the mass 20 times the acceleration A. So T cos alpha, so that's going to be 40 times cos alpha is going to be 4/5, looking at my triangle there. Take away the friction, well F equals mu r, and we know mu was 0.14. So 0.14 times r, let's write that in, equals 20A, no space. And using that, I can work out what A is. So 40 times 4 divided by 5 minus 0.14 times 172 divided by 20 gives me acceleration of 0.396 meters per second to the minus 2. Cool. Okay, so that's first bit. Second bit is a more wordy kind of explanation question. So crate is now pushed using the same handle. So there's a difference between pushing it down and pulling it up. Why would the acceleration be less? So we need to kind of think this through. If you imagine we're pushing this down, some of that push force, although it's moving it horizontally, some of that push force is now pushing it. It's really hard to do this. Is now pushing it into the ground. So like into the ground. Because of that, that's going to increase our reaction force. So we can say thrust pushes crate into ground. This increases the reaction force, and the reaction force, this increases friction, which decreases the acceleration. So there's a life lesson there. If you're ever trying to move something heavy, if you push down on it, it's not going to be any good. If you pull up on it, it'll be easier. So often pulling stuff from above is easier than pushing stuff from above. Or you can try and push it up from below, but whatever. Okay. Yeah, that's that one done. Good. Question 8. Let's zoom in a bit. This looks like a SUVAT question to me, but vector form. So we've got vector SUVAT for 8 marks, so 8 minutes on the timer starting now. Cool. And Kezi as well. Good. So the rest of you got 30 seconds left. See if you can finish it off. Okay. So part A is a show that, so that should be pretty easy. And part B, yeah. All right. So we know the initial velocity u is 2 minus 3. We know the displacement covered in that time is 7 minus 10. We know the acceleration is constant, so we got t is 2. We want to find a. So s equals ut plus half at squared. So we get 7 minus 10 equals 2 minus 3 times 2 plus half a times 2 squared. Run out of space, so oops, delete something I needed. 7 minus 10 there. So 7 minus 10 equals 4 minus 6 plus 2a. So we get 3 and minus 4 equals 2a. So therefore a is 1.5 minus 2. And we can find the size of a by finding the modulus of that vector. So 1.5 squared plus 2 squared, square root it, and we get 2.5. So we've done it right. Good. Okay, then things get a little bit more difficult, as is usually custom in these questions. Okay, so find the instant, at the instant it leaves A, the acceleration changes. So now it has a new acceleration. A is 8.8. Okay. Cool. At the instant it reaches point B, the direction of motion, so the final velocity is going to be lambda northeast, north 1, east 1. So northeast will be lambda 1, 1. So we need to know one more thing. We don't know the time. What we could find out though is the initial velocity, and the initial velocity will be the final velocity of the first bit of the question. So I wish I hadn't deleted all that now, but I did. So let's quickly go back through that. So our initial velocity for the first part, 2 minus 3. T was 2, and our acceleration was it 1.5 minus 2? I think that's what it was. So we v equals u plus at. So v equals 2 minus 3 plus 2 lots of 1.5 minus 2. So you can work out v, 2. So final velocity is going to be 5, and then minus 3 plus minus 4 minus 7, 5 minus 7. So that is my initial velocity for the second part of the question, and we're trying to find the time it takes to get to this point. Okay, so v equals u plus at again. This time v is going to be lambda 1, 1 equals 5 minus 7 u plus a 8.8 times by t. So we'll come up with two simultaneous equations. We get lambda is 5 plus 40, and lambda is minus 7 plus 8.8t. If we solve these simultaneously, we get 5 plus 40 is minus 7 plus 8.8t. So we get 12 is 4.8t. Divide 12 by 4.8, and we get t is 2.5. So well done, Kezia and Sam. Decent. Okay, on to the next one. How many are left? 9, 10, 11. Oh god. Three more. Three more questions in 24 minutes. It's doable. I don't know if it's possible or likely. Okay, so this one's a bit harder. Right, I'm just going to sketch this one out so you guys can actually see what's going on in the question. So we've got a wall, we've got a rod AB, which is attached via some string to the wall. So we've got point B, which I can't draw over there for some reason, point B, point A, point C, angle alpha. We got a particle P put onto the beam. We know the length of the beam is 2a, and we know that the particle is x away. We also know the mass of the beam, or mass of the plank, they called it, is m, and the mass of P, I'll just label P on there. Mass of P is, can anyone see it? I've lost it. 3m. Cool. Right, so let's zoom in a bit on this so you guys can actually see something. It's not too bad. I'm just going to go get rid of I think this question is leaking onto the next page. That's better. Cool, that's not too shabby. Alright, could you guys try this one then? So this is a 3, 4, 5, 10, 13 mark. Yeah, I don't think we're going to get much more than this one done today. 13 mark question, so 13 minutes on the timer. Should be pretty straightforward. Just be careful. You're going to need to resolve using moments and also vertical and also I think horizontal for this as well. Be careful where you put your reaction force from the plank onto the wall. That's going to be important. Ask if you need any help. I'll give you some hints because it is quite a long, tricky question. There you go. 13 minutes. There's no friction, Dan. I don't think. Oh wait, there is friction. I don't think you need to worry about friction, to be honest. At least I didn't when I solved this yesterday. Um, has it given us a coefficient? No. No, I don't think friction actually plays a part in this one. Yeah, I don't think we need it. Okay, as for reaction force, there's a vertical part and a horizontal part. Because the reaction force in this situation will be something like this. So you'll have a vertical part, VR, or of Ry, and a horizontal part, Rx. You don't really know what the angle is. So, yeah. Cool. All right, let's do this. Yeah, this one is pretty tricky. So, show the tension is that. Okay. Um, my diagram's horrible, isn't it? Let's get rid of the blue stuff I did for now. Okay, and I get rid of this. We don't need that. We don't need that either. Okay. So, we got some choices. We can resolve vertically, we can resolve horizontally, or we can take some moments. Hold on. Okay, and there's a few ways we can do it. Let's have a look at what we're trying to get to. We're trying to get to this 5mg 3x plus a divided by 6a. All right, I'm going to resolve about a. Reason being because the distance of particle P or mass P, whatever it is, box P, block of mass P, yeah. Block P is measured from A, and we've got X in our answer. So I'm going to assume, first of all, it has to be moments. It can't be just resolving up and down because X wouldn't make an appearance in the answer. And if we resolved about B, we would have something weird like 2A minus X, which we don't have. So I'm going to resolve about A clockwise. So just to make this a bit easier, I'm just going to take a photo of some paper. There we go. And so I've got a place I can actually do some writing. Cool. Maybe one more. Oh, did you choose photo? I'm going to take photo. That'll do. Okay, cool. So we're going to resolve clockwise about A. That color doesn't work. So we've got the weight of particle P, which I think was 3W. So you've got 3W times X. Plus we've got the weight of the beam, and it's a uniform beam. So we got I think that was W. Nope, sorry, I say W, I mean mg. So you got 3 mg times X plus mg times A, because that acts halfway through. And we're also going to have minus the tension, but it's going to be T. We want to work out how much tension is vertical, so it's going to be T sine alpha times 2A, and that should all equal 0. So sine alpha, if I look back through my question, I think it was 3/4 again. Yeah, the same as in the last question. So sine is going to be 3/5. So we're going to get 3x mg plus mga minus 3/5 of t times 2a equals nothing. And we're trying to resolve this, rearrange it to get tension equals. So I'll add all my tension stuff to the other side. So we get 6a over 5t equals, and I'm going to factorize out the mg. So we get mg 3x plus a, times it by 5, divide it by 6a, and we got the thing that they said there. So t equals 5 mg 3x plus a, and then divide down by my 6a to get the required expression. Cool. Right, next bit of the question. So they've told us the magnitude, and this gets a little bit confusing. Remember, the magnitude of the horizontal component of the force exerted on the plank by the wall is 2 mg. So we've got force coming off the wall, which is 2 mg. And we want to do that to find x in terms of a. So this time we're going to resolve horizontally. So horizontally that way, we've got 2 mg we've just been told about. The only other horizontal force is the tension. So we're going to get T cos alpha, and that should equal 0 because it's an equilibrium. Now T we just proved was all that stuff here. We know cos alpha is going to be 4/5, so we get 2 mg minus 4/5 of 5 mg 3x plus a over 6a equals 0. So let's put them both on, put the one on each side and expand and try and simplify. So we get 2 mg equals, so we're going to expand this and put it on the other side. So the 5's will cancel. So we're going to get 4 over 6 mg 3x plus a divided by 6a. Okay, now the mg's on each side will cancel. I can times both sides by 6 to get 12, divide by 4 to get 3, times the a up to the other side, and get 3a equals 3x plus a. Take a from each side to get 2a is 3x. And what we're trying to find? We're trying to find x. So x equals 2/3 of a. Cool. All right, we're getting somewhere. Next bit of the question is saying the force exerted on the plank by the wall acts in the direction which makes angle B with the horizontal. So we're now told about the reaction force this way. So there's the reaction force. And we're told that makes an angle beta with the horizontal. So I'm going to label that one beta. Great sketch, isn't it? We want to find the value of tan beta. Okay, so to do this, we could resolve and try and find the angle. Not going to do that. We already know horizontally this thing is 2mg. If we can find the vertical amount, then we can just use those kind of inner triangle like this and work out what this angle is. So this is 2mg. We're trying to find the vertical component of this force. And then we can find our angle. Cool. Oh, we got. Oh no, that's it. How have we run out of time? Okay. We will finish part C and part D tomorrow. Sorry about that, guys. I took too long explaining it. Maybe you want to try and finish it off in your own time, though. There's not much left, but yeah. So if you want to take a picture of that and try and finish it off, you can. Otherwise, I will speak to you guys tomorrow. Thank you. Cheers.